Hi, everyone, and welcome to today's webinar on using selective fidelity for immersive learning systems. I see you all trickling in here. Please make sure you have your chat panel set to all panelists and attendees. You want to make sure we have a lively discussion today. You can be you can be sharing any comments you have or questions throughout the hour. We want to get those addressed as we go throughout. So please make sure that setting is switched. You can also choose your audio, mic, and speakers, or choose to dial in via phone. Also, let us know where you're from. It's always fun to see kind of where people are from quick before we get started here. We're almost at the top of the hour, but it'd be nice to see where everyone's from. Montreal. I'm from Southwest Minnesota. It's beautiful here today. And let me know if you can hear me. I want to make sure everyone can hear me. So if you can hear me, just say yes. Okay, good. Thank you. San Francisco, Texas. We have Mike and Dennis are on the line here too. They're from Georgia and Pennsylvania, so kind of all scattered. India. Yes, Rich, it's rainy in Chicago. Alabama, Mexico City, Minneapolis, Lisa. Oh, LeSueur. Yeah, Jerry. I'm down by Slayton on Lake Chautauqua. So we're not too far apart. You're always on my way up to the cities. San Antonio, love it there. Jerry, you're from Fulda? Oh my gosh, small world. I know people in Fulda. I worked with some people in Fulda. I mean, it's only 12 miles from Slayton, so cool. Small town. Okay, got a good number on here so far. Again, if you're just joining us, this is the Using Selective Fidelity for Immersive Learning Systems webinar. My name is Carrie Zenz with Allen Interactions. Allen Interactions helps build adaptive organizations through custom learning and technology solutions. There's a lot of different things we do. We're going to share some of those things at the end. Please make sure your chat panel is set to all panelists and attendees. Paris, France, St. Paul. Sorry, I'm still looking at where you guys are all from. I think we're going to get started here. I wanted to let everyone know we are on Twitter today. So if you have a Twitter account, please look us up. We're at Custom eLearning. Those are the hashtags, Allen Webinar and Selective Fidelity Webinar. We'll be doing some live tweeting. I've got some other back channel support here today with Rich Peterson and Claire Letts. So they might be helping answering some questions in the chat for you as well. You see their names. Lots of times Claire will be sharing some resources too as well. So we're just going to get started here today. We are so thrilled to have Dr. Dennis Folds with us. He's our Chief Human Systems Scientist. He has nearly 40 years of experience in human performance and user-centered design projects and research. He has done a ton of work that's military-based, and even cockpit design for helicopters, all kinds of things. He'll touch on some of those with you. He founded Lowell Scientific Enterprises. He headed up the Human Performance Integration Program at Georgia Tech Research Institute for 35 years. So he is a heavy hitter in the industry here, and we're super thrilled to have him share everything he knows about selective fidelity. This is actually a methodology that he created, and it really helps guide businesses on how to make investment decisions when it comes to learning and technology solutions like immersive learning. And it also really helps focus around the learning experience and what's important for the learner and for that behavior change to occur. We also have Michael Hruska on today, and he's going to be moderating this hour. He is a technologist and a design thinking expert for Allen Interactions, and he has a ton of experience in the industry. He's worked on many projects, learning and technology related. So he'll be moderating this hour. He's going to kick things off for us. He's going to set the tone a little bit in the stage before he turns things over to Dennis. He'll also be monitoring the chat for us. And pulling any questions that you guys have throughout the hour and lifting them up to Dennis. So I'm going to turn things over to Mike now.
That was great. Thanks, Carrie. And good to see you again, Dennis. Hopefully I'll get to see you in 3D sometime soon. I love this space where education, training, and learning intersects with technology. In 1998, while I was in college, I had some experience in audio and video production. I got asked by a contact at the University of Pittsburgh to help build the distance learning and distance education technology program. And I did it, and I thought this is going to be absolutely amazing. Professors and expertise is going to be able to be distributed. This is going to be really, really cool. So built the classrooms, did all the technology stuff, and the technology was perfect. It was absolutely great. But the professors taught exactly the same way. And actually, some of our operators would get tipped to keep the audio on mute so that people could have a conversation in the classroom behind their hands along the way. And I thought, wait a second, with a little bit of thoughtful and deliberate design, the experience could have been much better. So I love this space. That was my first introduction to what I would call a suboptimal solution that could have had way more impact along the way. But I love this space where we can be really thoughtful about design and technology for supporting people to do and say the right things and at the right time. And I've known of Dennis's work for a number of years, and I've had the great pleasure of working with him on a number of projects over the last few years. And I think we all know that in many cases, a person working with you and teaching you one-on-one is quite effective. I play the guitar and a bunch of other instruments, and I learned from instructors and practice on my own. And I also never learned to play guitar from e-learning because it wasn't the right modality. And I don't know anyone, in fact, of all of the guitar players that I know, that learned to play guitar because of e-learning, although there are a lot of great lessons that are out there now. There are many things that we can learn, and in some cases, the right choice for something might actually be a more immersive type of technology where people can get a deeper experience. They can have the opportunities to practice, learn, fail, and build those skills towards mastery. And Dennis and I were working on a project a bit ago, and the project called for really designing very highly effective immersive learning, but also balanced with cost. Now, you can imagine that if you had or wanted to make a little bit of a VR solution for something, as an example, you could spend $30K and you could get something that might look cool and you could put it in Google Cardboard and put it on your head, or you could spend millions of dollars on that. The design question that I've been wrestling with, and which is why I've enjoyed collaborating with Dennis and using this methodology, is how do we spend the right amount of investment on the right things to have something that is actually quite effective in balance with the cost. As I said, you could spend very little and have something that's not great. You could spend too much and have a Hollywood level title. So how do you know where to prioritize your investment dollars? This is the methodology to help you think about that. So with that, Dennis, pass it over to you.
Thanks, Mike. So let's remember that about 11 years ago, in January of 2009, there was an event called Miracle on the Hudson, in which an airplane took off from LaGuardia, and the captain, known as affectionately as Sully, Chester or Ches Sullenberger, set the airplane down in the Hudson River, and everyone was saved. I was fortunate enough to chat with him about it at a conference where he was the keynote speaker. The thing that impressed me about it is he said he only did what came to him rather automatically because he had practiced it over and over again in a simulator. So it's not an instance of someone coming up with a wonderful, quick judgment, innovative on the spot. He did what he had already learned to do. So he learned to do this in a simulator, and he did what came to him naturally. Everyone was saved. Now, in contrast, I've flown thousands of times, and I bet a lot of you have flown a lot too. You hear the safety briefing over and over again, right? We've heard it. And I bet you all remember that your closest exit may be behind you because you've heard that over again. But when the passengers disembarked from that airplane, they did not do what they had been instructed to do. Only a few of them actually took the life vest off, and on a very small number of them deployed the life vest correctly. So anyway, this is a good example of where the right kind of learning environment creates the kind of behavior that you want in the real world conditions of interest, whereas the wrong kind of training or inferior training, though it's delivered consistently, didn't actually produce the behavior that you wanted in the transfer conditions. Next. Mike, would you talk about some of these examples of effective use of this kind of technology?
Yeah, there are a number of companies that are looking at more immersive solutions: VR, MR, XR, AR, and simulations. I think at the end of the day, there's a couple things that we want to do. We want to reduce cost. We want to reduce risk. Some people want to use less bullets or gas. Some people want behavior change. But most of all, it goes back to what Dennis was saying, that we really want to give someone something where when they have to perform, it's just natural ultimately for them.
All right, next. My experience with this actually began around the late 1980s. And in fact, one of the big events was the thing that happened on August the 2nd, 1990. I bet a lot of people listening today weren't even alive on August the 2nd, 1990. In case you don't remember, that is when Iraq invaded Kuwait. And President George H.W. Bush said this will not stand. And he ordered the U.S. military and our allies to liberate Kuwait. So the U.S. Army loaded up, went to the desert in Saudi Arabia, and our helicopters were there. And our helicopter pilots were there, but our training simulators were back stateside. They were big, expensive, motion-based simulators with a great visual dome and all that. And that's what the guys trained in, but they couldn't take the training systems with them. So I had some funding from the Army in the aftermath of that to look at lower cost solutions and to come up with ways to help them decide what kind of technology to invest in, how much they needed in terms of the visual system. Did they need a motion base for these simulators? What all kind of capabilities needed there? So anyway, that's where I got started with this notion of fidelity. So the first thing you think of is the physical fidelity of what's represented in the learning system. So the individual objects that are represented, how realistic are they, how detailed, and then comprehensiveness of all the things that you can feature in the training system. How close does that come to all the conditions that you might be interested in the real world? So we first of all think about visuals. We think about visual resolution, and we think about the speed at which it is updated. We think about the width of the field of view. Think about those things. Sometimes it's easy to forget the auditory piece. Okay, the auditory, in lots and lots of things that we want to learn, the auditory channel is a significant source of information, and it shouldn't be neglected. Things like a helicopter simulator, the tactile and haptic feedback, so the feel of the controls is important. You can contrast, though, thinking about the device, the training device or the learning system hardware, contrast that with behavioral fidelity. This is the fidelity of what people actually do when they're in the learning environment. So you could take a given piece of a given training system, have people do one set of things in there. They might be doing it with high fidelity, but another set of things might be low fidelity. Let's go to the next slide. This is the thing that I developed for the Army and worked on this a great deal over the years, to break the behaviors down into three dimensions: the sensory, cognitive, and psychomotor. The sensory fidelity is the correspondence of the visual and then other sensory inputs like auditory and tactile, correspondence with what they experience in the learning environment versus those things that are encountered in the real world conditions of interest, meaning the live environment. Psychomotor dimension is the correspondence between the responses, whether it's fine motor movements, things with their fingers or hands, or gross movements like moving their feet, walking around, and speech output. Those are the components of the psychomotor dimension. So the degree to which what they do with their muscles matches in the learning system matches what they do in the live environment is the degree of psychomotor fidelity. And then there's the cognitive. This is what they have to think about, the mental operations that they have to do. Things like remembering, calculating, deciding, making judgment, discriminating, identifying, recognizing things. Those are cognitive activities. And so these three dimensions each have their own level of fidelity in an immersive learning system. So let's think about the implications of that. Next slide. If we tried to have high fidelity representation of every single thing, all the visual objects that might possibly be of interest, all the auditory sources that might possibly appear, all the different kinds of objects that you might interact with your hands or your feet, all the different kinds of situations that you might encounter, and therefore the cognitive things that you might need to do. If you tried to have that in an immersive learning system, first of all, you might not be able to afford it. It might take way too long to develop, even if you could afford it. And then even if you had it, would it be worth what you spent on it? Selective fidelity allows us to customize in the sensory, psychomotor, and cognitive domains to get the level of fidelity that we need. Well, how do you figure out what you need? Let's go to the next slide. If we go with selective fidelity, then we can create conditions for learning in a way that's, first of all, probably less expensive, but immersive systems can be very expensive. We can also create things that, no matter how expensive they are, you can't readily create in real world conditions. So things like dealing with life-threatening emergencies. It's one thing for someone to learn to drive in a driving simulator. It's the basics of learning to drive. It's another thing for them to learn how to handle life-threatening conditions or situations like a high-speed chase for a law enforcement officer. Those are things that you probably want to train in an immersive system rather than in the real world. So if we make these decisions about the fidelity that's needed, it really needs to be driven by the behavioral fidelity that's needed for effective learning and not just the appeal of the fancy things that someone wants to put into their training simulation. Next. Let's think about some examples. There are cases where sensory fidelity is very important and the other two dimensions aren't. Similarly, psychomotor or cognitive could be important and the other two dimensions not. But sometimes it's two of them and sometimes it's all three of them. I'll think some examples. A good example of when the need for sensory fidelity is high, but the other two are not high, is if you need to learn to recognize objects. So one thing that people train to do is learn to recognize aircraft from their silhouettes. You may know somebody that they look up in the sky and see a plane flying across and they can say that's an F-16, and you don't know how they know it's an F-16. They might be able to see it from different angles and recognize the aircraft. Another thing that people can do learning like this is learn to recognize different plants by their foliage. Learn to recognize different birds by their call. So in those cases, it is the sensory fidelity that is highly important, whereas it doesn't really make much difference if they're learning to recognize aircraft, whether they write down the answer that it's an F-16, if they click out it on the screen, if they select it, from a list. It doesn't really matter how they go about indicating their response. So the psychomotor part's is not important. It's the sensory part. For that matter, it doesn't really matter what they're thinking about while they're doing this. It's only the sensory environments. Now, if they are learning to troubleshoot in like electronics maintenance, then the sensory dimension is high, but so is the cognitive. They've got to be thinking through the right steps in the right order, making the right decisions based on what they see. The psychomotor dimension is not particularly important there. It's not to say that it doesn't exist. They may have to do some things, take some things apart, but to learn to troubleshoot is to learn to see things and think about them and take the right steps at the right time. Sometimes psychomotor dimension is high and the others are low. Great example there is rifle marksmanship, right? So if you want to learn how to shoot a rifle accurately with an immersive learning system, all that really matters is what you do with your muscles. So what really matters is that you've got to hold it right, you've got to align it right, you've got to sight it in, you've got to breathe correctly, you've got to squeeze the trigger correctly. It doesn't matter whether you're looking at a high fidelity representation of a target or just a bullseye with some, with some things to aim at. Doesn't matter what you're thinking about while you're doing this. All that matters is the psychomotor part. On the other hand, if you're trying to learn self-defensive actions, like things related to judo or martial arts or something like that, then it's really, really important that you react to the sensory environment with it, that it has high fidelity, and that your psychomotor activities are rendered with high fidelity. Okay, that really matters. Now let's think about cases where all three of them are important, where it's important that you have the sensory environment right, the psychomotor environment right, and the cognitive environment right. This would be things like CPR training, right? So if you're learning to do CPR with a simulator, it's important that you pay attention to the things you're supposed to pay attention to with the person that you're trying to revive, that you're trying to help. So the signs that you're getting from them. It's important that you make the right actions in the right way, that you apply the right amount of force at the right place and at the right rhythm. And it's also important that you think through and make the right decisions about what you do as you go through. So all three of those are important. On the other hand, you could have cases where sensory and psychomotor are high, but the cognitive fidelity requirement is low. So things like precision landing, when you're parachuting, so when you're skydiving, this is something that what you're thinking about while you're doing it is not as important as that you see the right things in the environment, you hear the right cues as you're doing this task, and that you move your hands and your feet and your arms and your body in the right way. Another great example, I guess, though I don't know of anybody that's ever learned to do this in an immersive environment, is learning to thread a needle, right? So if you're learning to thread a needle, you've got to be seeing things correctly and moving your hands correctly, a very precise movement. Doesn't matter what you're thinking about while you're doing it, okay? If anybody develops an immersive simulation to learn to thread a needle, I'd like to try it out. Another example would be the sort of intricate soldering that someone might have to do when they're doing repairing of electronics. Again, the sensory environment's got to be high, and the psychomotor's got to be high fidelity. What you're thinking about while you're doing it may not matter. Now, there's some interesting cases where neither the psychomotor nor the sensory dimensions are important at all. All that really matters is the cognitive dimension. Great example here is learning to play chess. If you had an immersive learning system where you're going to learn to play chess, it would be of no value to you to have this high fidelity representation visually of chess pieces. Okay, that wouldn't matter at all. It wouldn't matter if you had these tactile gloves that you could seem to be picking up a chess piece and moving it on a real board. That wouldn't help you. It's okay for you to have simple visual representations of chess pieces. It's okay for you to do something like click on a piece on your computer screen and then click on the square you want to move it to. All that's fine. What matters about learning to play chess is how the opponent behaves. Okay, the opponent's got to, first of all, behave like a good chess player. It's also got to match your level of skill. You know, if you set someone down in a chess game and that chess opponent was playing at a very high level, it just beats you real quickly every time. You've got to play at the right cognitive level and learn of the different openings and learn the different end games and learn the different things that you can do, and you go through that progression. Now, are there examples of things where all three of them are low? Probably. We probably all go through this annually with your compliance training, right? So your awareness of your company's, I don't know, drug-free workplace policy or something. It probably doesn't really matter what the sensory environment is. It doesn't matter what you're thinking about. It doesn't matter exactly how you click it. You've got to be exposed to it. So we won't worry about the cases where all three are low. All right, let's go to the next slide. Here's an example of a high fidelity rendition of a pine tree versus a low fidelity, right? So the image on the left, of course, if you pay attention, it's not perfectly symmetric. It's you can see the individual needles. You can see that each branch is a little different, and you can see some things about the bark. Why in the world would you need that? On the right is a simplistic representation of a tree. Could be a pine tree, could be a spruce, could be something else. It doesn't much matter. So if you think about when would you need a high fidelity representation of a tree? Well, maybe if you're learning to tell different pine trees apart, you're trying to tell a loblolly from a longleaf from a bristlecone, then you need high fidelity representations of them. Maybe if you're trying to learn to spot signs of disease on a pine tree, you need a high fidelity representation of the tree and of the indicators of the disease of the tree. But if what you need is a bunch of trees in the environment, and let's say with my helicopter simulator, you're learning to land on a landing strip, the purpose of the trees is to give you a source of cues about your altitude as you're landing. They don't need to be high fidelity. They don't need to have representation down to the individual needle. You just need to have a good general representation of their height relative to other objects is what you need. So don't pay for the rendition of every needle on the pine tree when that's what you don't, if that's not what you need for the purposes of the training. Next. Unfortunately, to do this, you've got to get down in the details, right? This is not some easy solution where you just make up your answer. You've got to start by identifying what are the tasks that we're going to learn in this learning system, okay? You've got to identify the domain. Now, sometimes you are dealing with a job that someone's already analyzed and they've already got a task list compiled. You can use that and go for that and do the analysis on that list of tasks. Sometimes, though, no one's done that. So you've got to go through the process of developing that task list based on a comprehensive job task analysis up front. Of course, the skills that you're after might be only for a subset of those tasks. So you got to identify what is the domain of tasks that you're interested in learning in this learning system. Then you have to identify the range of environmental and situational conditions in which the task should be performed. So there's maintenance procedures that you might have to do in the shop versus in the field. There's things that you might have to be able to do in daytime conditions versus nighttime conditions. Things that you might have to be able to do when time is not a source of pressure versus when there is a time limit on being able to do those things. Lots and lots of different conditions in a range of conditions in which tasks might have to be performed. Those all have to be thought through. And given that you have the domain of tasks and then the range of conditions for each of those tasks, you sort of define a matrix here. This is where we can go through this matrix task by task, cell by cell, and identify how important the different dimensions of fidelity are. So you can start by assessing the sensory domain first and go through each cell in this matrix and say, is it important or not? You can use a binary scheme, so it's yes or no, a green check or a red X or whatever symbols you'd like to use. Sometimes people are more comfortable with a trinary scheme, though, where you say, well, I wouldn't say it's high fidelity, but it's not unimportant, so maybe it's medium, or we just don't know. We've got to look into it further. We don't know. So the trinary scheme is sort of reflected here in this slide of things where high fidelity is needed for the sensory dimension, where you know that low fidelity or no fidelity is needed because it can't be done. And where you're not sure or you think that it's in the middle. So you get this scheme here. And then you go through this same exercise for the cognitive and the psychomotor dimensions. Now, it doesn't matter if you do all the tasks, do their sensory dimension, and then go back and do them all with psychomotor and all with cognitive. Usually find it a little easier to go task by task and just do all three as you go. But this is what you want to characterize. Does it have high versus medium or low sensory fidelity requirements, high versus medium or low cognitive dimension requirements, and high versus medium or low psychomotor dimension requirements with respect to fidelity needed for effective learning. Next slide. This is the way that you can drive the definition of your requirements for your immersive learning system. You want to take those things that have high sensory fidelity and come up with a specific list or other ways of defining it of the objects that have to be represented in high fidelity. You're usually going to be thinking about the visual things first. Will keep telling you, don't forget about the auditory and the other senses. If you forget about the auditory, what you're apt to get is either dramatic music in your learning system or gimmicky sound effects. And sometimes people find this so aggravating that they just want to turn it off. For lots and lots of the things that we do, however, the auditory dimension is an important part, is an important source of information, and therefore it's an important part of having an effective learning system. So if you think about things like automobile mechanics working on an engine, how that engine sounds to them may be as important as anything that they see. So there's lots of things. You think about driving your car, how it sounds is a source of information to you. You may be able to detect that something's wrong by the way it sounds. So don't forget about the auditory when you're doing this. Okay, so the high fidelity requirements, you should compile those. And then as you're thinking about it, sometimes the different environmental conditions also have to be represented with some fidelity. So for example, if you think about someone learning to drive, then you might need to learn to drive in the fog. Okay, so this is a different environmental condition that would have to be represented. Then go to your psychomotor fidelity, things that are rated as needing high fidelity. Again, you want to make a list of the objects. They're often hardware replicas or sometimes the real thing that needs to be included in the learning system. Has to be represented with high fidelity. And any other kinds of psychomotor actions that have to be performed. One of the biggest challenges that we have in immersive learning systems now is when you need to walk around. So think about having to simulate walking around. How do you do that? Right? So that can be a challenge for the psychomotor actions. And then finally, the high cognitive fidelity requirements. This one will be particularly challenging. So if you think about when things require high cognitive fidelity, think about how you're going to generate that. Well, you don't generate that with visual objects. You don't generate that with psychomotor features like, hardware replicas. You've got to create conditions. And sometimes this is through computer generated characters. So you may have other, avatars or whatever in the immersive learning systems. Sometimes it's the randomness or the unpredictability of responses that creates the cognitive challenges, the complex social interactions and so forth. So these things can be the source of a lot of complexity in the learning system of how to create the cognitive fidelity. Let me give you an example of a training system that I reviewed for federal law enforcement. This was, they were trying to train law enforcement agents how to interview people. Now, lots of interviews that law enforcement officers conduct are pretty routine, just the facts, man. So the basic things of asking the right questions in the right order. But this particular system was to try to help officers learn to build rapport with a witness, to learn to read the signs of stress or deception or withholding information or other sources of uncertainty when they were interviewing someone. In this particular case, they had some computer generated characters, but mostly it was actors and actresses playing the part of responding to questions that the law enforcement officer would pose. Law enforcement officer had to first do things to build a rapport. If they didn't do those things, they would get a different set of responses from the person they were interviewing than if they did. If they built a rapport, then they had to go through the process of trying to read the facial cues to understand the tone of voice, the presence of eye contact or lack thereof in the person they were interviewing, read the body language, and then they had to produce the right kind of tone of voice themselves, the right kind of facial features. They had to produce the right kind of body language themselves. So imagine putting together a simulation in which someone was going to learn to interrogate a potentially non-cooperative witness who might give you more information if you only did the interview correctly. Imagine trying to create that learning system. There's lots and lots of cognitive fidelity requirements to be imposed that have to be created in a very sophisticated way. All right, so you get the idea of how challenging this can be. Next slide. Usually when people are learning something reasonably complex, they go through a progression of stages in the cognitive activities. Early on, we may be learning the names of things or the definition of things or the meaning of key terms, recognizing things, recalling things, understanding the basics. That's early. Then as you progress, then you learn about relationships among things. You learn the general rules. You learn about exceptions and variations in those rules. Okay, so early on, the cognitive activities are kind of focused on individual things. And then it switches to relationships among things or general rules that applies to those things. And then finally, in the more advanced stages, you make judgments. You identify novel ways to apply what you've learned, or you combine things in creative ways. You wouldn't want to start out requiring people to do those kind of cognitive activities when what they really need to do is learn the different objects and learn what things are called, learn what the terms mean, learn sort of how they go together. So this progression of fidelity requirements, so accommodating transitionality in someone as they go through the learning process can be an important part of an immersive learning system. So your computer generated characters might become increasingly sophisticated and more realistic as the learning progresses. Next. Key methods here. Start out with a task analysis. Okay? Call it something else if you need to. No one wants to go do a task analysis. You got to identify the specific task to be learned. If you don't identify this set of things, then you will be hopeless at being able to ever identify your fidelity requirements. The fidelity of what? You've got to know what the behaviors are that you're targeting. And for every one of those, consider is there a variety of conditions in which that task has to be performed that will make a difference in how we conduct the learning experiences in this immersive learning system. So you define this matrix of tasks by conditions and let that be then the basis for making the following judgments. Go through the sensory environment. This is where you're probably going to have the most things to choose, most choices to make when you're looking at an immersive learning environment. What are the visual objects that have to be represented in high fidelity? Don't forget the other senses. Don't forget the auditory. Don't forget the tactile and the haptic. But you'll think about the visual objects first. Don't be persuaded unduly by someone who brags on the high resolution of the visual objects. Not long ago, talking to someone who was bragging on, rendering every blade of grass in the environment. Why do you need every blade of grass? Do I need every needle on that pine tree? Depends on what I'm learning. Sometimes every needle on that pine tree, some of them discolored because of disease, is important. But unless that's what you're learning, you probably don't need every needle on the pine tree rendered. Go through the psychomotor requirements. This is going to help you identify special objects like control devices that need to be part of your learning system. Imagine trying to teach someone to drive a car when there is no steering wheel. Right? There's lots of things about driving a car you can learn without a steering wheel. You learn about starting it. You learn about different rules of the road, but you can't actually learn lane control without a steering wheel. You can't learn speed control without an accelerator and a brake. So the things that you will need, either the actual replicas present or some virtual representation of them that you can interact with in special ways. So that'll be your next level. Then come to the cognitive part. So this is going to drive the attributes of things like computer generated characters, other actors that are involved, or other kind of situations that are created. Now, when I talk about these other actors, they don't necessarily have to be represented visually. In the case of my chess simulator, there's no reason that it has to appear to be a person making the moves. That doesn't necessarily have to have a voice associated with the opponent. What matters is the cognitive complexity of how they play the game. So keep those things in mind. All right. Next.
Hey, Dennis, if you don't mind, there was a question that I was present with that I imagine that you might have some comment on. Is there a concern where someone might get overwhelmed if the cognitive fidelity is too high?
Especially if they're early on. So the chess example is a good one. If you're not going to learn to play chess if you lose every game in just a few moves. Okay. So that's an example. And then any of these things that involve some sort of role playing by some other element in the learning system. If it gets too sophisticated too quickly, you probably won't be able to learn. Okay. So learning how to interview someone, I gave that example. Yeah, you want to go through the basics of getting somebody's name and, you know, getting that initial exchange of pleasantries and getting the facts down. But so you want to get those things, master those things before you start learning or worrying about reading facial expressions and tone of voice and shifting eye contact and those kind of things. So yeah, they can be overwhelming. It can be overwhelming if the cognitive complexity gets too sophisticated too quickly. This framework, while it can be used to drive the requirements for a immersive learning system that hasn't been developed yet, it can also be used to predict the effectiveness of one that has been developed and is being proposed. Right? So as a matter of fact, I actually had a fair amount of work for the Army and other customers using this method to predict the effectiveness of training, or more accurately, to predict the capability of a training system to provide effective training if it was used correctly. So you go through this same process. You define the task by condition matrices, and then you can assess whether the fidelity that is provided by the proposed training system at least meets, if not exceeds, the fidelity that's required. You worry about it exceeding it if it's going to mean that you pay too much for it, okay? Otherwise, you're mostly worried about deficiencies. So you might worry about things that, well, certain aspects of the task aren't well represented. I'll give you an example there. A training system that I reviewed had a speech communication requirement. So someone was supposed to learn to talk over the radio with someone else and coordinate what they were doing. And in this particular case, the speech recognition system did not work very well. And so the person had to spend way too much time thinking about exactly how they were pronouncing the words so the computer speech recognition algorithm would perhaps correctly recognize what they were saying. So they couldn't think about the task they were trying to do because they were trying to get the daggone computer to understand the words they were saying. It really distorted the cognitive dimension. So the deficiency for that was enough to actually keep the training system from being effective. So you can do this, and if you find deficiencies, so things that have to be remedied, then if they can't be done in this learning system that you're looking at, you got to find some other way of providing that training. If training is required, if learning is required across a whole different range of conditions that aren't represented in the learning system, then you got to provide it somehow, and that's going to be cost. So this gives you a basis for predicting not only the effectiveness or the capability for it to be used to provide effective training, but also for calculating your ROI, because you'll also have to invest in some other way of providing the training. So that's important to keep in mind. This is not just a way to define requirements, it's a way to predict capability or capacity for a learning system to provide overall effective training. All right, next slide. The things I've talked about today might have seemed like that they were only applying to things that were complete VR, virtual reality. But this method also applies to other kinds of extended reality systems. So the way those terms are being used today is not always uniform, but usually when you enter virtual reality, it means that the entire environment is being generated virtually. Augmented reality means that you're primarily in a live environment, but you're getting some sort of supplementation, some sort of augmentation through virtual technologies. And mixed reality is sort of somewhere in, between the two. So if you think about, gosh, what was the movie? Who Framed Roger Rabbit, that had real characters and cartoon characters coexisting in the same scene? That's an example of a mixed reality system where much of the environment is real, is live, but significant parts of it, not just augmentation, but significant parts of it are provided in a way that's virtual. So it's mixed reality. This method applies to all of those. Okay, so an example there that I worked with a company was we're developing a maintenance learning system in job aid. So they would want to teach people how to perform certain maintenance activities first in complete VR. So you did not actually have to be where the actual aircraft were, nor to have, some complete hardware representation of an aircraft. You could learn the maintenance procedures on this aircraft using the VR system. And then if you were actually in the presence of the aircraft, then it was switched to an AR mode in which it would recognize the real objects that were there, and then it would give you overlays, right? It'd give you some prompts as to what you should do next, or where the next, where's the next panel you're supposed to remove, and what is it you're supposed to check in there. So these were both a learning system and then a job aid to use. And so anyway, this method applies to these other kinds of systems just as well as it does to a completely virtual reality learning, immersive learning environment. All right, next slide. So let me review the key points. The selective fidelity is our approach to determining what attributes that you need in an immersive learning system, because it's usually not wise to try to pay for high fidelity everything. Okay. Now, if you do, and it doesn't matter to you, then you're probably not going to go through the following steps. Most of us, though, will have a limit on how much we can spend on these immersive learning systems, and we want to make sure that we're spending our money wisely. So our methods emphasize understanding the behavioral fidelity requirements and letting that drive the investment decisions. So you've got to figure out what are the tasks that have high sensory dimension fidelity requirements, what are the tasks that have high cognitive fidelity requirements, and what are the tasks that have high psychomotor fidelity requirements. And that includes tactile and haptic feedback, as well as actually manipulating things with your hands and possibly with your feet. These dimensions are the source of the effectiveness of training as done in an immersive learning system. getting these right is the key. And you can use this framework either to specify a system that you want to have developed for you or to assess a proposed solution. You can apply this to any kind of extended reality system. The selective fidelity is our approach. Behavioral fidelity is our orientation to defining what the fidelity requirements are. Okay. Mike, I think it's time to go back over to you.
I think you might be right. We're getting close to the end of the hour, and I'll make you a pledge that we're not going to use the whole hour. We're going to give you at least 5 or 6 minutes so that you can get a cup of water or tea or whatever you need to do to take a little break. I know everybody's been working hard remote along the way, but thanks, Dennis. As I said, it's a pleasure working with you and using these types of methods to make sure that the things that we build, we're not just rolling out the technology and hoping for the best. We're being thoughtful and we're being deliberate with our analysis and design along the way. Someone at Ray just asked a question here. I'm trying to decompose it. Dennis, I don't know, can you see the chat or?
Let me bring it up.
Yeah, so the question is, can we talk about the difference to consider depending upon whether you have to train people to interact with a specific device, for example, a particular model and brand of a network router versus training for more general skills like how to configure a router with no particular emphasis on any one model or brand?
Yeah, so this is kind of a classic question in kind of learning general principles versus specific procedures or device specific. And so you probably want to start learning general principles because they'll need to be applied, and your example is a good one. If you can understand basics of networking, then there's a whole lot about any model and brand of a network router that this will apply to. So if you can build the fundamentals in a more general framework, then you can spend far less time and do it more efficiently to teach about the specifics of a given model. So to do this, you probably want to do it in a way that you not only learn about one model, but you learn about, say, a handful of different models. So you don't want to probably just learn about the specifics of one particular model for most immersive learning. Now, you could imagine training someone, and this is all you're training them for, you just want them to learn this one thing. That can certainly be the case. The more general case, though, for learning is you want to learn principles first and then specific procedures second.
Super. Carrie or Rich, will you pop to the next slide? So I can tell you there's a ton of different ways this actually could be applied. I threw some of the use case domains in here, but this could be manufacturing, repair, equipment setup, maintenance, calibration, verification, recruiting, onboarding, business, soft skills, medical. There's a lot of places, and what we really want to try to encourage folks to think about is, where could you apply it? And I threw some case study ROI stuff in there. We're going to send some stuff out to you guys as a follow-up, because if this is something that you have the potential to do in your organization, it's hard to get everyone on board for a science project. But if you can help your organization understand that there's a business impact to be had in terms of making it better for people or better for the business, reducing the time, increasing the effectiveness, whatever that might be, I'm going to share with you as a follow-up from this webinar, some of the research, some of the case studies, some of the things that are out there, so you can do some further reading. But we like to help, and I really appreciate you guys taking the time to hear about this. There'll be a recording, and if you want to share this with any of your team members, you may certainly do that, or your colleagues. But at Allen, we like this space, this intersection between people, process, and technology. And we have upcoming webinars that Carrie will tell you about in a second. But whether it's strategic analysis or analysis and design or custom, really anything from media to software, we can help you and we can help your team build the capabilities. We also have something called the Allen Academy. So if you have people that you want to scaffold their instructional design skills, you want to learn the edge of mobile learning, and you want to build your team, we can help there too. And we like to help and we like to share. So thank you guys for your time today. And Carrie?
Yeah. Thank you both. Thank you, Dennis, so much for that presentation. There's a lot of people saying great session, very informative, solid. So I think it was really helpful. And thank you, Mike, for adding some color and some information into the chat throughout. We'll share those links back out through the email, as Mike said, with the recording. And then we have this as a webinar coming up. Claire will put the link to this one in the chat. This is going to be on May 20th on creating your playbook for organizational change management with Dr. Christina Bars. And I think we might have a few other people involved in that too. And then Claire will also throw some links in the chat to the Allen Academy if you want to check that out, but we'll include some of that in the follow-up email with a recording as well. So thanks again. Grab a tea, coffee, take a little break before you get on to whatever you got to do next, and have a great rest of your day. Thank you so much for joining us.